So I want you to picture something for a second. Imagine you are, say, 200 feet up in the air.
Oh, it sounds terrifying already.
Right. Well, imagine you are strapped to the steel lattice of a massive telecommunications tower.
Okay, I'm with you.
The wind is just howling, pulling at your harness, and your focus is, entirely on this heavy wrench in your hand. But here's the thing. The most immediate hazard in your environment right then, it makes zero sound.
Yeah, and it casts no shadow either.
Exactly. Because you are actually immersed in this high-power radio frequency field. It's this invisible architecture of electromagnetic energy that's just pushing data all across the city.
It is wild to think about.
It really is. And the only thing standing between you and severe physical harm is this tiny piece of plastic clipped to your chest, measuring a threat that you literally cannot see.
Right. And if that small piece of plastic is, well, if it's measuring the environment using the wrong mathematical framework, it might actually be lying to you.
Which is horrifying.
It is. Because the worker on that tower, they believe they're perfectly safe.
Yeah.
When in reality, they are actively absorbing dangerous levels of non-ionizing radiation.
Okay, let's unpack this because the sheer scale of this blind spot is staggering.
It really is.
Today, we are doing a deep dive into a really fascinating briefing from TMG Test Equipment. It's all about our ARPANSA RF exposure monitoring for telecom workers and really focusing on why accuracy is everything.
Yeah, that is the core of it.
Because our mission for you today is to understand why tracking this invisible force isn't just about, ticking some WHS compliance boxes.
Oh, not all?
It's about the very real psychology of workplace safety and the massive dangers of using the wrong measuring stick on the job site.
Spot on. Because the core issue here isn't whether telecommunications workers face exposure. I mean, they absolutely do. That's a given.
Right.
The real conflict is that the specific device is designed to protect them. The monitors that translate this invisible physics into actionable safety data, they are frequently failing.
And what's crazy is that they aren't failing because the technology is broken, right?
Exactly. They are failing because site managers and, well, procurement teams are fundamentally misunderstanding the regulatory physics of the environment they are buying for.
Okay. Before we get into the whole procurement mess, we should probably look at the mechanics of why these environments are hazardous to begin with.
Yeah, that makes sense. We need to define what's actually happening to the body.
Right, because when we talk about radio frequency or RF energy from telecom infrastructure, we are dealing with non-ionizing radiation.
Correct. Which is very different from ionizing radiation.
Like X-rays.
Exactly, like X-rays or gamma rays,
Yeah.
which actually have enough energy to rip electrons away from atoms. That causes direct DNA damage.
Yikes.
Yeah, bad news. But RF energy doesn't do that. It interacts with the human body primarily through thermal heating.
It's essentially just agitating the molecules, isn't it?
That is exactly it. It is dielectric heating. You have to remember, the human body is mostly water. And water molecules are dipoles. They have a positive end and a negative end. So when you step into a really strong alternating electromagnetic field, those water molecules, they try to constantly align themselves with that rapidly changing field.
Just flipping back and forth.
Constantly.
Yeah.
And that frantic movement creates friction. And, well, friction generates heat deep within the body's tissues.
Wow. Okay, so if I'm a worker up on that tower, or, maybe I'm even just a solar panel installer working on a commercial roof near some shared antenna setup.
Very common scenario.
I am basically standing in the splash zone of this energy, like being a lifeguard at a public pool.
That's a great way to look at it.
Right. You expect to get splashed a little bit. You just need to know if the water level is rising way too fast to stay safe.
Exactly. Some exposure is completely expected in these trades.
Right.
The goal is keeping it within safe limits.
But I have a question about that solar installer.
Sure.
They aren't actually touching the telecom equipment. They are just on the same roof. Are they really absorbing enough energy to cause this kind of thermal heating?
If we connect this to the bigger picture, this is where distance becomes incredibly deceptive.
How so?
Well, RF fields don't just magically stop at the edge of the antenna. They propagate outward and they bounce off things. Metal structures, roofing materials, you name it.
Oh, I see.
So an electrical contractor or, say, a structural engineer might be working in what we call the near field of an antenna.
Near field. Got it.
Yeah. And in that near field, the electromagnetic waves haven't fully formed into a predictable, smooth pattern yet.
It's just chaotic energy.
Very chaotic. You get these pockets of intense energy. Constructive interference where waves combine to create these massive hotspots.
Oh, wow.
So that worker might be 10 feet away from the actual antenna, but they could be standing in a hotspot that is rapidly elevating their core body temperature.
And because humans don't have, like, biological hardware to sense RF energy, they won't feel a thing. At least not until a thermal load completely overwhelms their body's ability to cool itself down.
Right. They start getting fatigued, their cognitive function drops.
And they probably just think, oh, it's a hot day working in the sun.
Exactly.
Yeah.
They attribute it to the hot sun rather than the invisible electromagnetic field they're literally standing inside of.
Which is the exact biological reason why we require objective, real-time monitors.
100%.
Yeah.
A worker cannot manually calculate the inverse square law of radiation dispersion while they are hanging from a lanyard.
Yeah, I'm pretty sure nobody is doing complex calculus on a ladder.
No. The device has to do the math for them.
But here's where it gets really interesting, though. The math is not universal.
No, it is absolutely not.
Because the TNG briefing heavily emphasizes that for Australian work sites, simply buying a top-rated RF monitor off the global market is actually a massive liability.
It is a huge trap.
Right. Because if I'm a site manager, my first instinct is to look for a device that says, I don't know, FCC approved from the US.
Sure. Or one that carries an ICN-IRP certification.
Yeah, ICN-IRP, the International Commission on Non-Ionizing Radiation Protection. Those are basically the global gold standards.
They're very well respected, yes.
Yeah. So why can't I just buy those, hand them out to my crew, and just call it a day?
Because a global guideline is fundamentally different from a local legal standard.
Ah.
ICN-IRP provides exceptional scientific guidelines, but they are based on global averages and broad protective thresholds.
So it's sort of a one-size-fits-all approach.
Exactly. But the regulatory landscape in Australia, WHS, Work Health and Safety, does not legally operate on ICN-IRP guidelines.
Okay, what do they use?
It operates on a specific standard mandated by ARPANSA.
The Australian Radiation Protection and Nuclear Safety Agency.
You got it. Specifically, we are talking about the Radiation Protection Series S1 standard, which was introduced in 2021.
Okay, wait, but if an ICN-IRP monitor captures the raw field strength anyway, couldn't a smart site manager just buy the cheaper international device, download all the raw data at the end of the shift, and then just mathematically convert it to the ARPANSA S1 standard for the safety audit?
I mean, theoretically, you could run that mathematical conversion post-exposure.
Right.
But that's assuming the device logged every single frequency variable perfectly throughout the day.
Yeah.
Which is a big if.
Right, okay.
But more importantly, you cannot retrofit a real-time alarm.
Oh, wow. Yeah.
The entire point of the monitor is to warn the worker before they absorb dangerous thermal loads.
Before it happens. Not on a spreadsheet at 5 p.m.
Exactly. So if the device is hard-coded to alert at an ICN-IRP threshold, and the ARPANSA legal threshold for that specific frequency band is actually tighter,
the device will just stay silent.
it stays completely silent while the worker is actively overexposed according to Australian law.
That makes so much sense. It's like, okay, it's like bringing a tape measure written entirely in inches to a job site that legally mandates the metric system.
This is a perfect analogy.
Right. The tape measure is functioning perfectly well in a vacuum. It is accurately capturing the distance.
But it is speaking the wrong WHS language.
Exactly. And when the site auditor asks for the safety logs, your data is completely misaligned with the legal requirements of the site. You're giving them inches when they need centimeters.
And what's fascinating here is how that misalignment degrades the entire safety culture of a site.
Oh, I bet.
WHS managers are very, very familiar with this concept called alarm fatigue.
Yeah, where the alarms go off so much, people just ignore them.
Right. It's a psychological phenomenon. Workers just stop responding to safety alerts because they go off way too often.
Oh, no, the boy who cried wolf.
Exactly. But in the context of RF monitoring, alarm fatigue is rarely caused by a lazy worker. It is almost always caused by a mismatched regulatory threshold.
It's the Goldilocks problem.
Precisely. Let's look at the first scenario. Overestimating exposure.
Okay.
Consider a monitor that overestimates the threat because its algorithms aren't mapped correctly to those specific ARPANSA S1 curves.
So it thinks the danger is higher than it really is.
Right. So the worker is navigating a site. Maybe they're trying to repair a mast under a really tight deadline, and their monitor is constantly shrieking at them.
Oh, man.
The cognitive load of a high decibel alarm at 200 feet in the air is immense. It's incredibly stressful.
And the worker probably knows from their own experience that they aren't actually in the danger zone, but the device is just panicking anyway.
Exactly. And what happens? If your kitchen smoke detector goes off every single time you make toast.
I don't stop making toast. I take the battery out of the detector.
Exactly. And taking the battery out of an RF monitor or, just mentally tuning it out or wrapping duct tape over the speaker, that leaves the worker entirely blind to a hazard that can actually cause severe tissue damage.
That is terrifying. But you said there was another scenario.
Yeah, the inverse scenario is even worse. The silent danger.
Underestimating the exposure.
Right. The monitor underestimates the field because it's using a broader international guideline. Or maybe its alarm thresholds were just never configured properly by the procurement team.
So the alarm doesn't go off when it should.
Correct. The worker is standing right in a hot spot. Their body's thermoregulatory system is fighting to shed the heat. Core temperature starts rising.
And like we said earlier, cognitive function slows down.
Which is a highly, highly dangerous state for someone operating heavy equipment at height.
Yeah, you don't want brain fog on a tower.
Definitely not. And the whole time the monitor says everything is green, no alarm.
Wow. This really points to a massive disconnect between the people buying the equipment in an office and the people actually wearing it out in the field.
There is a huge disconnect.
Let's look at this through the lens of a hypothetical site manager. We'll just call them Manager A.
Okay, Manager A.
So Manager A is tasked with equipping a team of riggers for a big nationwide 5G rollout.
Very common right now.
They look at the budget, they look at a catalog of RF monitors, and they just fall into every single trap the TMG briefing outlines.
It happens all the time.
So first, they buy an international device instead of an ARPANSA aligned one, which we just established, creates false alarms and silent dangers. What is the next trap Manager A is going to hit?
The next trap is that they drastically underestimate the frequency range requirements of modern telecommunications.
Okay, break that down for me.
So Manager A might buy a fleet of legacy monitors that only measure up to, say, 6 or maybe 8 gigahertz.
Is that bad?
Well, historically, that might have been sufficient for 3G and some of the early 4G bands. Those operate at lower frequencies.
Okay.
And lower frequencies have very long wavelengths. They propagate outward like a broad floodlight. They cover large areas smoothly.
Right, but Manager A is working on a 5G rollout. And 5G fundamentally changes the physics of the site, doesn't it?
It completely changes it. 5G utilizes millimeter wave frequencies.
Yeah.
We're talking about bands that push up into the 20, 30, and even 50 gigahertz range.
Wow, that's a massive jump from 8.
It is. And the physics of millimeter waves are entirely different. Because the wavelength is so incredibly short, the energy doesn't flood an area like a light bulb. It is highly directional.
Oh.
It acts much more like a laser beam.
Okay, so if Manager A's crew is wearing a legacy monitor that caps out at 8 gigahertz, and a technician steps directly into the path of a 5G millimeter wave transmission, the monitor is functionally blind.
Totally blind.
It's like having a sensor designed to detect ambient room lighting, but it's completely incapable of seeing a high-powered laser pointed right at its face.
That is a brilliant way to phrase it. The worker is absorbing intense, concentrated RF energy, and the monitor is registering zero hazard. It just doesn't see that frequency.
That is the technological reality. And because the worker relies on that monitor as their only sensory input for RF energy, they will just remain in that beam, absorbing the energy until the thermal damage is done.
Exactly. Manager A thought they were being smart. They thought they were saving the company maybe 10% on the procurement budget by buying cheaper legacy units.
Yeah, looking good on the spreadsheet.
Right. But they have actually stripped their workers of any meaningful protection against the very infrastructure they are actively building.
Which brings us to the engineering solution that was presented in the briefing, the Wave Control WaveMon RF60.
Yes, a very impressive piece of kit.
The brief describes it as the only personal monitor purpose-built for the ARPANSA RPS S1 2021 standard.
That's right.
But just putting aside the regulatory compliance for a second, the raw engineering required to build this device is fascinating. It monitors from 100 kilohertz all the way up to 60 gigahertz.
Yeah, achieving a flat frequency response across that massive a spectrum in a device small enough to clip to a harness is an immense engineering challenge.
I can't even imagine.
Think about it. 100 kilohertz represents massive, slow-rolling electromagnetic waves.
Right.
And 60 gigahertz represents incredibly tight, high-energy millimeter waves.
The laser beams.
Exactly. The sensors inside the WaveMon have to accurately capture the electric field strength of both of those extremes simultaneously.
Wow.
Then it has to run the mathematics against the complex curve of the ARPANSA S1 limits and output a single comprehensible safety percentage to the worker in real time.
And it actually solves the international problem too, doesn't it?
It does.
Because if Manager Aid's company wins a big contract in New Zealand or over in the EU, they don't have to buy a whole new fleet of monitors for the crew.
No, they don't.
The device can just toggle its internal algorithms to measure against IC and IRP, FCC, or EU directives.
Yeah, it's a localized tool with true global adaptability.
But there is a secondary feature here that shifts this from just being a physical safety tool to a real legal defense tool, and that is GPS logging.
Oh, this is crucial.
Why does a radiation monitor need to track a worker's physical location? I mean, isn't the radiation level enough?
This raises an important question about the reality of WHS audits and post-incident investigations.
Okay.
Measuring exposure is really only the first half of the equation. Proving that you measured it accurately is the second half.
Ah, I see.
Without GPS, a monitor simply records that it detected, say, a 70% exposure spike at 2:0 p.m.
Just a time and a number.
Exactly.
Yeah.
If a regulatory body audits that site, or worse, if a worker files a health claim regarding that exposure, the site manager has a data point floating in a complete void.
They have no context.
None.
Yeah.
They have to rely on human memory to figure out where that worker was standing on a complex, multi-tiered infrastructure site.
Yeah, like, I think Bob was on the north side of the mast. Maybe? I don't know.
Precisely the kind of ambiguity that completely fails compliance audits.
Right.
But by integrating an altimeter and GPS logging directly into the RF exposure data, the WaveMon ties that invisible field strength to a definitive three-dimensional coordinate.
Oh, wow. So you get the exact height and location.
Yes. The site manager can pull the data and see exactly where the hot zone is located on the tower.
That's amazing.
It proves not only that the worker was alerted, but it actually allows them to map out the site's RF topography for any future work.
So what does this all mean for the defensibility of the data? Because, data is only as good as the sensor capturing it in the first place.
Very true.
I noticed the briefing heavily emphasizes NADA-accredited calibration, which is provided through TMG test equipment. Why is calibration such a big deal here?
Well, NADA is the National Association of Testing Authorities. It is the peak body in Australia for accrediting laboratories. And you have to remember, an RF monitor is a highly sensitive piece of test equipment.
Right.
And it is constantly exposed to brutal environmental conditions out on these sites. Extreme heat, freezing winds, humidity, physical shocks from being dropped.
Just getting battered every day.
Exactly. Over time, the internal components experience what we call sensor drift.
Sensor drift, yeah.
The baseline measurements slowly shift out of alignment.
So the device might start reading a 50% exposure as only a 40% exposure.
Exactly. And if the device isn't regularly recalibrated back to an absolute traceable standard, the data it produces becomes legally meaningless.
Wow, meaningless.
Totally. In a court of law or during a strict principal contractor audit, uncalibrated data is just rejected outright.
Because you can't prove it's accurate.
Right. TMG provides that NADA-accredited calibration. That ensures the WaveMon's readings remain a constant source of empirical truth rather than just a rough estimate that's drifting over time.
When you look at the entire ecosystem of RF safety, it really seems like buying a cheap monitor is the most expensive mistake a company can make.
Without a doubt.
I mean, if a device triggers constant false alarms because it doesn't understand ARPANSA thresholds, it grinds the entire work site to a halt. It destroys the safety culture.
Yes, it does.
If it misses a 5G transmission because it maxes out at 8 gigahertz, it places a human being directly in the path of serious thermal injury.
It's a disaster waiting to happen.
Accuracy, ARPANSA alignment, and a legally defensible audit trail. That is really the trifecta required to actually survive and operate safely in these environments.
It transforms RF exposure from this invisible, terrifying hazard into a manageable, measurable variable.
Yeah, that makes it much less scary.
Right. A solar panel installer doesn't need to understand the molecular physics of dielectric heating.
Thank goodness.
They just need a device on their belt that speaks the right regulatory language and tells them exactly when to step back.
The infrastructure we rely on every single day, just to stream a movie, make a call, stay connected, it is built by people swimming in an invisible sea of energy.
It really is.
The least we can do is give them the right tools to measure the water.
Before we conclude, though, there is a broader implication to consider here.
Oh, well, what's that?
Well, Currently, it is the telecommunications workers and specialized contractors who wear these monitors, right?
Yeah, they're on the front lines.
They are acting as the canaries in the coal mine for RF exposure. But as 5G networks densify and millimeter wave transmitters are integrated into, street lights, bus stops, the very fabric of our urban environments, this invisible architecture will eventually encompass us all.
Wow. Yeah, I didn't think about that.
It makes you wonder, as the ambient energy of our cities increases, how might the average citizen one day need to understand or even interact with the invisible frequencies we are living inside every single day?
That's a wild thought to leave on. The invisible world is only getting denser, that's for sure.
It is.
Next time you look up and see a technician strapped to a high-voltage mast, you'll know exactly the unseen forces they are navigating and the incredible engineering required just to keep them safe. Thanks for joining us on this deep dive. We'll catch you on the next one.